Hi, welcome to another lesson at EDU Solutions Institute. Now, today we are continuing on our CSEC chemistry syllabus, and today's topic will be acids and bases. Now, in last week's lesson, we looked at the final aspect of mole concept, where we talked about the molar concentration and the mass concentration. So stay tuned as we look at a new topic of acids and bases. Now, the term acids is a popularly used word that it's used outside of the realm of chemistry. Now, what exactly are acids? What exactly are bases? Now, the term acids have to do with a substance that when it is dissolved, it produces or donates H plus ions. And H plus ions are hydrogen ions. So therefore, if you put these substances to mix with another substance, or just the basis of dissolving in water, it will actually split apart and give away some H plus ions. So what that tells us is that all acids must have hydrogen in their formula. Right? Now, in acid anhydride are non-metallic oxides that when they dissolve in water, they form acids. So for an example here, we have NO, nitrogen dioxide, right? Well, nitrogen monoxide, sorry. And in this case, we mix this with water, we more than likely will get probably a nitric acid combination. So therefore, it's a non-metal oxide. So nitrogen is a non-metal. It's mixed with oxygen. And when we dissolve it in water, it gets the H from the water. And hence now we have an acid. So notice here that there is a H in this acid. So if we go again and mix this acid with another substance, it will break apart and it will give this hydrogen as a free ion. Now, a base is a substance that neutralizes an acid. Now, what does the word neutralize mean? To neutralize means we are actually reducing the effect of acids. So we know that acids are corrosive, they will burn, they are sour in taste for the ones that we can taste, like citric acid, right? Now, to neutralize that effect, we use a base, which means to make it not corrosive and burn a lot, we can reduce the effect by mixing it with a base, right? So that's what a basic solution is. And then if we mix these two together, an acid and a base, then we always get a substance called a salt. And therefore, a salt is a substance that is formed from the metal of a base and the non-metal from an acid. So if we look at this example here, we have HCl, acid, hydrochloric acid, plus NaOH, sodium hydroxide, which is the base. Then the metal from our base will combine with the non-metal part of the acid and we get NaCl, which is commonly what we call table salt. So as you can see, we get a salt based on the reaction of an acid and a base, where the metal of our base reacts with the non-metal from our acid. Now we have some substances that can actually exist as being an acid and as a base. And these substances are called amphoteric substances, which in terms it can behave as an acid and it also can behave as a base. Now, how can we know if a substance is acidic or if it's basic? Now, we use a basic information here which we call a pH scale. right? So a pH scale classifies if a substance is acidic or if it is basic. Now it's a range of numbers from 0 to 40. Now, even though it's not here, I'll put a pH scale on this video that will represent that each number here has a unique color. Alright, and we're going to get to that unique color later on in this video. So it ranges from 0 to 40. Everything from 0 to 6 is classified as acidic. 7 is the middle one, which is our neutral. That means it's not an acid, it's not a base. And then from 8 to 14, it's classified as basic solutions. Now, we see here that from 0 to 3, it's an acid, but we are classified as strong acids. And strong acids means that when they dissolve in water primarily, they will give all their hydrogen ions. Right? So that's what strong acids are. Now, weak acids from 4 to 6, they will have some hydrogen left after they dissolve. So an example would be that ethanoic acid, where if we dissolve it in water, it breaks off here to give this hydrogen, but we also have these hydrogens there that's not broken off. So that's a weak acid. It hasn't given off all its hydrogen. Now we go from 8 to 10, which is our weak bases, and then from 11 to 14, we call them our strong bases. Right? So remember I said each number has a unique color. Now that unique color is important because it can tell us, is it a strong acid, is it a weak acid, strong base, or is it a weak base? Based on use of a universal indicator. So an indicator tells us it's a substance or material that we use to distinguish a specific class. Is it acidic or basic? So these are substances that will determine the acidity or basic properties of a substance. So a universal indicator here is one way of finding out a substance is acidic or basic. And what we do is if we have the substance here in a container, we tip some universal indicator, right, using a pipette, get some drops there, then we mix, and then it gives us a specific color. That specific color will now be compared with the pH scale color to see which number it falls on. So if it falls on a number based on its color, then that will tell us if it's an acidic substance or a basic substance, and also it tells us if it is strong or weak. Then we have a simple way, which is the one we normally use primarily at the CSEC level, the litmus paper. Now the litmus paper is just a strip of paper that we will dip into a substance and it changes color. Now this one has its limitations. It only can change color blue or red. Right? So for red, it tells us that it is on this end, which is the acidic aspect, but it cannot differentiate if it's a strong acids or weak acids. And if it is blue, after you dip within the substance, then it's on this end where it's a basic. And again, it will not tell you if it's a weak base or if it's a strong base. Alright, so that's how you know if a substance is acidic or if it is a basic substance. So that's it for us this week, guys. Hope you understand the basics of an acid and a base. And I'll see you next week where I explore more on this simple concept of the acid and base. Thank you.